Hi everyone, welcome to your first maths lesson of the week. Just before we start, a quick note about the arithmetic. The arithmetic I've set up differently. Some people are having difficulties finding the questions on the slides and things like that. So you'll notice that this week I have put the questions on the answer sheet. Now I know that some of you are going to be tempted just to do them all in one go because they don't take very long, and I know some of you really like arithmetic as well. But remember, the point of arithmetic is that it's supposed to be a daily practice. The reason it's supposed to be a daily practice is because we are not learning something new. It's all about practicing skills, and when we're practicing skills, we want to do little and often. So I really want to encourage you still to try and do like we would in school, just 3 questions a day. So the top row of questions you might do on the first on Monday, and the second row of questions on Tuesday, and so on. I hope that all makes sense. I know that some of you might have to do them all in one go because you only have the access to the computer on one day. If that does apply to you, don't worry. But the best thing to do is little bit and often. So still try and be doing 3 questions a day. Okay, a glimpse forward to what we are learning this week. We're going to start with some revision of fraction basics, some of that stuff, again, that we just need to make sure is in our long-term memory. And then, of course, we need to be moving on. So this week, we are looking at fractions of quantities. By that, I mean fractions of amounts, and there are a few different types of problem there. Then we're moving on to percentages. Percentages are new to us. So we are going to start with the very, very basics and then build our way up from there. So firstly, a little bit of revision time for fractions. Okay, I know we've done this a lot and some of you are doing this really, really well, but it doesn't ever hurt to practice these things again, and that is fraction and decimal equivalents, okay? Some things to remember. One thing is to remember place value. Okay, now you can see here, I've written out some common mistakes that I saw when we have been doing this. And if this is you, don't worry, you weren't the only one that made this mistake. Lots of people said, okay, if you just let me grab my pen, you can see, okay, so I have 1/2, and people said, oh, 1/2, well, that must be 1.2, because I can see the 1 there and the 2 there, it must be 1.2. And therefore, like, a quarter must be 1.4. And things like that. Now, I can completely understand how that mistake has come about, but we need to be aware that that is not how we convert from a fraction to a decimal. Let's work out why. Here is one whole, okay? One whole thing. Let's call it a pizza, okay? One whole pizza, that is equal to 1, okay? Now, if I have a half of that pizza, I've got no whole pizzas and half a whole pizza, okay? I do not have 1 and 0.2 pizzas. So you can't just immediately just take out the vinculum and replace it with a decimal point, okay? Of course, half a pizza is now equal to 0.5. That is a common fraction decimal equivalent. A half is equal to 0.5. That is one that we should have in our memory by now. Okay, and remembering, as I've said at the bottom here, that a fraction is the same as the numerator divided by the denominator. Okay, so if I have 1/2, what I'm saying there is I've got 1 whole and I've divided it in 2. The same way that a quarter is 1 whole divided by 4. Okay, that is one way that we can look at fractions when we're looking at fractions of 1 whole. Okay. Therefore, when I have a bigger denominator, like I do in a quarter, that means my actual fraction of the pizza is smaller. So let's look at this pizza here. Now, that is 1 whole pizza. If I split it in half, you can see that the denominator is 2. And if I split it into quarters, where the denominator is 4, you can see that each of the segments is now half as big as it was before. So the bigger the denominator, the more parts I'm splitting it into. So those are some things that we absolutely must remember about fractions. These should be doable by now for all of us, okay? These are things that we just need to know. And now we have, and there are lots of ways that we can remember these, but the bottom line is that we need to have these things in our memory before we move on. Now, let's have a little think again about place value. Let's have a look at 0.1. I've got 0 in the ones column, and I've got 1 in the tenths column. So I've got 1/10. I've got nothing else. I've got no whole ones, and I've got 1/10. So which fraction is that going to be equivalent to? Well done if you identified it was that one. Let's move on to the next one. I've got nothing in my ones column. I've got no tenths, and I've got 1/100th. So all I've got is 1/100th. Can you find where that would be as a fraction? Well done. If you realised it was that one there. Next, I have 0.25. Can you remember which fraction 0.25 is equivalent to? Well done if you said it's quarter. Now, the reason I know that is because I know that if I had, for example, the number 100 and divided it by 4 to find a quarter of it, that would be 25. Can you see the relationship between 100 divided by 4 is 25 and 1 whole one divided by 4 is 0.25. You can see that my answers here, that is 100 times less. I've divided them by 100, if you can see the relationship there. So more that I just need to remember, of course, 0.5 is equal to a half. 0.75 is equal to 3/4. Now, another way I can remember that, if I can remember it's really handy to do this, if I can remember that 0.25 equals 1/4, then I know that 0.5, which is 2 lots of 0.25, is a half, or 2/4, which is equal to a half, isn't it? And 0.75 is equal to 3/4. And then, of course, 1 is equal to 4/4. So there are all the different ways I'm going to work with quarters. And once I know in my head, remember over and over again, 0.25 is equal to 1/4. Therefore, all of those other fractions make sense. Last but not least, I have 1, which must be equal to, for example, 3/3. Now remember, when any fraction has the numerator and the denominator as the same number, that fraction is equal to 1. One of your tasks in this lesson is going to be matching up these fraction decimal equivalents. The answers are here for you. Watch the video, go to the task, and either do it now or you can wait till the end of the video. But the answers are here in the video, so I will know if you have not watched the video because you will not get the answers to those ones correct. Moving on, one extra one that is going to help us out. Now, these ones here, 0.1, 0.01, 0.25, 0.5, 0.75, and 1, they're ones that everybody needs to know. You absolutely must know and remember these. This next one is something else that will be good to know for, and it was going to help us maybe a little bit in the future. Okay, so let's have a look at this table. I have the fraction 1/2, which could be represented like this, couldn't it? Here's a bar, and I've split it in half. So there's 1/2 of it. And I also know, of course, from my previous lessons, that a half is equal to 0.5. So let's have a look at a quarter. So I've split it in half, and then each of those halves, my half on the left and my half on the right, I'm going to split in half again. So now I have 4 equal parts, just like in my fraction, a quarter, and I want one of them. Can you see how this shaded section here is half of this shaded section here? Half of it, isn't it? So what you can see is I'm halving here. So I started with one whole and I halved it, and then I halved it again. And you can see the denominator gets twice as big this time, which means I'm splitting it into twice as many parts, which means those parts are half as big each. And you can see that same relationship here as well. Half of 0.5 is 0.25. What about if I wanted to do that again? So this time I'm going to have my same bar. I'm going to start by splitting it into half, so over 2. Then I'm going to split into quarters by splitting those into halves again. So that's in quarters, just like my one above. How am I going to split this into eighths? I need to split each of these quarters into half again. 1, 2, 3, 4. So how many have I equal parts have I split the bar into now? Well, 1, 2, 3, 4, 5, 6, 7, 8. One of them is equal to 1/8. Can you see how each time my denominator gets twice as big, from 2 to 4 to 8, the amount of the bar I'm taking is getting half as big, from a half, and half of that is a quarter, and half of that is an eighth. Now, how do I find 1/8 as a decimal? Well, it might not be very easy for me to do 0.25 divided by 2, but I can have a think about some other things I could do to help me out. I could look, for example, at the number 50. So I know that 50 is half of 100. Half of that is 25. So what's half of 25? It's 12 and a half, 12.5. So what I've done here is I've taken these decimals, and instead of doing the calculations with tricky decimals, I've done them with whole numbers instead. So I can see that the relationship here, 50, 25, 12.5, what's the relationship going to be here then if I'm halving each time? 0.5, 0.25. Well, the answer is going to be 0.125. So this fraction decimal equivalent here might help you out in the future. 1/8 is equal to 0.125. Okay, time to break fractions down a little bit longer. So remember that the denominator tells us how many equal parts we're splitting something into. Now, we talked about this at the beginning of the video. A half means we have one whole and we're splitting it into 2 equal parts. There is one, and there is the other one. That's what the denominator tells me, how many equal parts I'm splitting something into. Okay, now the bigger the denominator, the more equal parts I'm splitting something into. So that's a half there. A quarter would look like this. An eighth would look like this. Now you can see each time the slice of the pizza that you're going to get if you have 1/8 is much, much smaller. It's really important for us to remember that we might get a question that says, oh, which is bigger, a 20th or a 10th? we might go, well, obviously it's a 20th because 20 is a bigger number than 10. We have to remember what fractions actually are. We are splitting a whole thing or a set into this many equal parts. So the bigger the denominator, the more equal parts we're splitting something into. So here are two things that we can use fractions for, okay? Fractions as part of one whole. Let's have a look at this word problem. Tommy ate a quarter of the pizza. How much is left? So this time I have one whole pizza and a quarter of it. So I know it's been split into quarters and 1/4 of it has been eaten. So I've got one whole pizza and I'm subtracting a quarter of it. What have I got left? Well, that was 1/4 that was eaten. I have a quarter there, a quarter there, and a quarter there. So how much do I have left of the pizza? Well, I have 1, 2, 3 quarters. So those are the types of questions we might get when we are talking about fractions as part of one whole. But remember, we also might get questions where fractions are part of a set. And now what we have to do is work out what the question is asking us. Is it saying there was one pizza, something like that? Or if you have a look at the example on the right, you'll see this a set of something, a number of something. So there were 12 balls. So this time, I'm not talking about one thing, like one pizza or one cake that people are taking fractions of. This time I've got a set of something. I've got 12 balls. 1/3 of them need pumping up. So how many is that that need pumping up? Well, what I can do is I could draw out, couldn't I, the 12 balls. Like that. And I now need to split them into 3 equal groups because my denominator tells me that. So I've got 12 and I need to split them into 3 equal groups. So what I'm doing is 12 and I'm dividing it into 3 equal groups. What is 12 divided by 3? Well, it's 4. So if I take one set there, one set there, and one set there. Now, they don't look all exactly the same. They're not arranged in the same way, but each of them is an equal group because it contains 4 balls. So I have 12 in total. They've been split into 3 equal sets. One of those sets is equal to 4 footballs. And let's have a look at this last question. There were 12 balls and 2/3 of them needed pumping up. So how many is that? Well, I know that I have 12, and to find 1/3 of them was 4, wasn't it? So I did 12 divided by 3, this gave me 4. So 4 is 1/3 of 12. I want 2/3, I want 2 times that many. So I have to take that 4 and multiply it by 2 to give me 8. And I can just go back to my drawing to check, can't I? I've got 2/3 of the footballs need pumping up. So here's 1/3, and here's another third. How many footballs in those 2/3 together? 1, 2, 3, 4, 5, 6, 7, 8. Now remember, whenever you are working out, you should feel free to make drawings and diagrams and things for yourself. Okay, let's have a quick look at this place value chart, and it's going to help us with fractions and decimals. Okay, now these that we're going to deal with. If we have a place value chart like this is a whole number. Now we're super confident with these. If I've got 300, 4 10s and 1 1, I have the number 341. I absolutely know that. I've got no fractions, I've got no decimals, I've got nothing like that. But now I'm starting to deal with numbers that are less than 1, or numbers which have parts of them which are less than 1. My next place value column along, remember, is the tenths column. Now, where is my decimal point going to go on this place value chart? It always goes between the ones and the tenths. It goes there. For example, if I had 4 hundreds, 7 10s, 3 1s, and 6 tenths, I say that number as 473.6. The decimal point never moves, okay? The decimal point never moves. Sometimes the numbers move around, but the decimal point never moves. Now, we'll draw a line under that. Let's firstly think about ones, okay? So here are my ones. At the moment, I have 3 ones. How many ones can I get in this column at most? Can I, for example, have 4 ones? Yes, I can. I can have 4 in my ones column. I can have 5 in my ones column. 6, 7, 8, 9. Can I have 10 ones in this column? For example, could I have the number 470.6? No, I can't, can I? I can only ever have 1 digit in each column. I can't have that. Remember, as soon as I get 10, then those 10 get grouped together and they get transferred over here. So that would then become 8. It's exactly the same system with my tenths as well, and exactly the same as you see with my hundredths. Now, again, I have hundreds, tens, ones, tenths, and hundredths. Where is the decimal point going to go? Can you remember from that last slide? Well done if you remember that it goes here. It always goes between the ones and the tenths. This is because this is the barrier here where I'm stopping dealing with whole numbers. Ones are my smallest whole numbers, aren't they? 1 is my smallest whole number. I'm starting to deal with fractions of 1. So my decimal point always goes between the ones and the tenths. For example, in the number 472.17. And that is exactly how I say that. And remember that each time I move 1 place value over to the right, each time I start a new column, that is worth 10 times fewer. Okay, so a tenth, like that, is 10 times bigger than a hundredth. And vice versa, a hundredth is 10 times smaller than a tenth, which is 10 times smaller than 1, which is 10 times smaller than 10, which is 10 times smaller than 100. Okay, look at those numbers. Can you see how each time they're getting 10 times smaller? 100 divided by 10 is 10. 10 divided by 10 is 1. Now, sometimes I can't stop there. Sometimes I need to have numbers which have fractional amounts in them, and that is exactly where decimals help me. So if I divide by 10 again, I get tenths, and dividing by 10 again, I get hundredths, and that would keep going to thousandths and tens of thousands and 5, 6, 7 decimal places down the line. For now, we are only really worried about tenths, hundredths, and sometimes thousandths. Okay, here is your independent task for this lesson. It is just revision. It is things that we have done already or things I've spoken about in the video. The first job is to color code the matching fraction decimal equivalents. Remember, those answers were given to you in the video. So if you've watched this video, you can go back and watch early in that video. It is when we were it was back here, wasn't it, at this point of the video. Now, challenge 2 is you are telling me decimal equivalents to an eighth. That was on the following slide. So as long as you paid attention to that, you are fine. And then this challenge 3, you just need to fill in the gaps and then tell me about it in terms of place value. Okay, so for some of us, this is going to be an absolute breeze and just a little bit of revision. And for some other of us, we still might need to watch the video. It's absolutely fine, but just do your best and let us know if you have any problems. Over to you.